Let's look at solving simultaneous equations using the elimination method. However, in these examples, unlike in the first video on using the elimination method, the coefficients of none of the variables are the same. Now, in order to use the elimination method, the coefficients of either, well, in this case, x or y would have to be the same. And we don't have it as the same in any of these equations. So there are a few things that we have to do before we can go ahead and use the elimination method. First, let's just label our equations. This is equation 1, and this is equation 2. Right? Now, if I want to say eliminate x, right? What I do is I look at the coefficients of x, which are 2 and 4, right? And I ask myself, what is the LCM of 2 and 4? Well, the LCM of 2 and 4, the lowest common multiple of 2 and 4 is 4, because both 2 and 4 can go into 4 without leaving a remainder. Now, since in equation 2 I already have 4x, I need equation 1 to also have 4x. So what I will do is I will multiply that entire equation 1 by 2, since 2x times 2 gives me 4x. And then I will end up with 4x plus 3y times 2 is 6y, and then 4 times 2 is 8. This is my new equation 3. All right. So now in equation 2 and in equation 3, I have 4x. So since I have the same coefficient of x, I could go ahead and use the elimination method. So the coefficients are the same. Now what I do is I look at the signs. Well, 4x in equation 2 and 4x in equation 3, the sign of both of them, they're both positive 4x. And when you have the same signs, you subtract the equations. Because remember, the whole purpose of using the elimination method is to get rid of one of the variables, right? So I'll say 4x. I'll say equation 2 take away equation 3. All right, so I'll say 4x take away 4x is 0x. Y take away 6y is negative 5y. And then negative 2 take away 8 is negative 10. And then I could go ahead and solve that equation. So this will be negative 5y is equal to negative 10. So if negative 5y is equal to negative 10, then y is equal to negative 10 divided by negative 5, which will give me positive 2. And now that I have what y is equal to, I could go ahead and substitute that into any one of the equations. I am going to use equation 2. So substitute y is equal to 2 into equation 2. Now it doesn't matter which equation you substitute it into. You'll still get the same answer. Well, you should once you do your algebra correctly. So wherever I have y in equation 2, I'm going to replace it with 2. So I'll say 4x plus 2 is equal to negative 2. So therefore, 4x is equal to negative 2 take away 2, which would mean that 4x is equal to negative 4, and therefore x will be equal to negative 4 divided by 4. That gives me x is equal to negative 1. So the solution of this pair of simultaneous equations will be when x is negative 1, y is 2. And to check if your answer is correct, you need to substitute those values back into the original equations to see if it works out, right? So if x is negative 1, that means it'll be 2 by negative 1 plus y, which is 3, so 3 times 2. Sorry, y is 2, so 3 times 2. Let's see what that gives us. 2 by negative 1 is negative 2 plus 3 by 2, which is 6. So that's negative 2 plus 6, which is equal to 4. So it substitutes correctly into equation 1. Now you need to check it for both equations, right? Even if it substitutes into one equation, it may not work for the next one. So let's check it for the other one. We have 4 by -1 plus 2. Well, that would be 4 by -1 is -4, and -4 plus 2 is -2. So my answer is correct. All right, let's do another example. Say we have 3x minus 2y is equal to 1, and then 4x plus y is equal to 5. This is equation 1, and this is equation 2. Now, it doesn't matter which variable you choose to eliminate. You could eliminate equation 1, sorry, x, or you could eliminate y. In this one, though, I'm going to eliminate y. And the reason is that I have the coefficient of y here, though it's not stated, is 1, right? So I have 1 and 2 there, and the LCM of 1 and 2, well, the LCM of 1 and 2 is 2. So that means I wouldn't need to do anything to equation 1. I would only need to multiply equation 2 by 2 so that the coefficient of y will become 2. So let's do that. So equation 2 times 2, you're going to multiply every single term in that equation by 2. So 4x times 2 is 8x. And then y times 2, sorry, is 2y. And then 5 times 2 is 10. This is my new equation 3. All right. Now I want to write my two equations that I'm going to work with next to each other. So I'm going to be working with equation 1 and equation 3 because they both have the same coefficient of y. All right. And you know that that is a criteria for solving simultaneous equations by elimination. So I'm looking at equation 1 and equation 3. Now, if you notice, they have different signs, right? In equation 1, I have a negative, and in equation 2, I have a positive. So this is negative 2y and positive 2y. When you have different signs, remember the objective is to get negative 2 and 2 to be 0, right? So you're going to have to add those because negative 2 plus 2 will give you 0. So what we're going to do here to eliminate y is we're going to add the two equations together. And a few seconds ago, I said I want to write my two equations next to each other. I'm going to write equation 1 right under equation 3 here. So this will be 3x minus 2y is equal to 1. I just wrote it over, right? That's equation 1. And now to get rid of it, like we just established, we're going to add the two equations, right? So we're going to say equation 3 plus equation 1. That means every term, all the corresponding terms, I'll add them together. So 8x plus 3x will give me 11x, and then plus 2y minus, sorry, plus 2y plus negative y. Well, 2 plus minus means minus, right? So 2 minus 2 will give me 0y, and then 10 take away 1 is 9. All right, so I have here 11x. Oh my gosh, I made a mistake. Sorry. Not 10 take away 1. I'm supposed to add them. It's supposed to be 10 plus 1. So that would be 11. So 11x is equal to 11, which means x is 11 divided by 11, which is 1. So you see how easy it is to make a mistake, right? That was a genuine mistake I just made. Remember, I'm adding the two equations, so I have to add all the corresponding terms. So now that I have x is equal to 1, I can substitute x is equal to 1 into any one of the equations. Let's do it into equation 1. So wherever I have x, I'm going to replace it with 1. So I have 3x, which means I'll have to write 3 brackets 1 to represent that that's 3 times 1. So 3 times 1 minus 2y is equal to 1. So then 3 take away 2y is equal to 1, which means that minus 2y, now you have to keep that minus in front of the 2y, right? That's the symbol of, or the sign of the 2y. So minus 2y will be 1 take away 3, which means that negative 2y is equal to negative 2, and therefore y is equal to minus 2 divided by minus 2, which means that y is equal to positive 1. So the solution here would be when x is equal to 1, y is also equal to 1. And we could check our answer to see if it's correct by substituting x is 1 and y is 1 into both equations 1 and 2. So that will be 3 by 1 minus 2 by 1, which is the 3 take away 2, which is 1. So it's correct there. We check it in the second one. 4 by 1 plus 1 by 1 is 4 plus 1, which is 5. So it works. Our answer is correct. All right, let's look at this one. 3x plus 5y is equal to 6 is equation 1, and 2x plus 3y is equal to 5, equation 2. Now, none of the coefficients of x or y is the same, so we need to choose which one we're going to eliminate. Let's just think about eliminating x, right? Now, if we're eliminating x, we're going to look at 3 and 2. We ask ourselves, what is the LCM of 3 and 2? Well, the LCM of 3 and 2 is 6. It's not 6x in any of them, so that means I have to do two things. I have to multiply equation 1 first by 2, which will make 3x become 6x, and then I'll multiply equation 2 by 3 because it'll make the 2x there become 6x. So let's do that. So I have equation 1 times 2, since 3x into 6x is 2, and every term I multiply by 2, so 3x times 2 is 6x. 5y times 2 is 10y, and 6 times 2 is 12. So this is my new equation 3. And now let's multiply equation 2 by 3, since 2x times 3 will give me the 6x. 3y times 3 is 9y, and 5 times 3 is 15, and that is my equation 4. Now that I have the same coefficients in equation 3 and 4, I could go ahead and eliminate by subtracting the two equations. And the reason I'll subtract is because 6x and 6x, they're both positive. So when you have the same signs, you subtract the equations, right? So I'll say equation 3 take away equation 4. Well, 6x take away 6x is 0x. 10y take away 9y is y, just y. And then 12 take away 15 is negative 3. So therefore, y is equal to negative 3. And now that I have what y is equal to, I could go ahead and substitute that. Oops, I was writing substitute x. Substitute y is equal to negative 3 into any one of the equations. Let's look at equation 1. Wherever I have y in equation 1, I will replace it with negative 3. So this will be 3x plus 5 times negative 3 is equal to 6. So then 3x minus 15, because 5 times minus 3 is minus 15, is equal to 6. So then 3x is equal to 6 plus 15, which means that 3x will be equal to 21, and therefore x will be equal to 21 divided by 3, which leaves us with x is equal to 7. So the solution of this pair of simultaneous equations will be x is equal to 7 and y is equal to negative 3. And then you substitute these values into the original equation to see the two equations to see if it works out. So if x is 7, that'll be 3 by 7 plus 5 by negative 3. So that's what? 3 by 7 is 21. Take away 15, which is 6, so it works there. And then 2 by 7 plus 3 by negative 3. Well, that would be 14 take away 9, which is 5. So it works. The solution is correct. Let us do one more. Okay, so let's say I have 2x plus 5y is equal to 16. That's my first equation. And then the second one is 3x minus 4y is equal to 1. This is equation 2. Now in the previous example here, I had 2 and 3x, and I knew that I had to multiply by 3 and 2 to get 6x, right? But since we did one like that already, let's look at when you have, let's eliminate 5 and 4 instead, right? So the LCM of 5 and 4 is 20. So I will multiply equation 1 by 4 since 5 times 4 is 20. All right, so let's do that. Equation 1 times 4, every term times 4, 2x times 4 is 8x. 5y times 4 is 20y. 16 times 4 is 64. So that is equation 3. And then I multiply equation 2 by 5, since 4 times 5 is 20. So every term, let's do it, equation 2 times 5. 3x times 5 is 15x. Minus 4 times 5 is minus 20y. And then 1 times 5 is 5. So this is my new equation 4. All right, so now I could go ahead and eliminate y because the coefficient is the same. However, you must note that the signs are different. And when you have different signs, you add the equations. So I'm going to say equation 3 plus equation 4. So 8 plus 15 is 23. So this will be 23x. 20 plus minus 20 will be 0. So that'll be 0y. And then 64 plus 5 is 69. So this is 23x is equal to 69, which means that x is equal to 69 divided by 23. So x will be equal to 3. And once we have what x is equal to, we could go ahead and substitute it into any one of the equations, right? So substitute x is equal to 3 into, let's say, equation 1. Wherever I have x in equation 1, I'm going to replace it with 3. So that will be 2 by 3 plus 5y is equal to 16. So then 6 plus 5y is equal to 16, which means that 5y is equal to 16 take away 6. So therefore 5y is equal to 10, and therefore y would be equal to 10 divided by 5, which means y is equal to 2. So the solution of this pair of simultaneous equations will be x is equal to 3 and y is equal to 2. And of course, as customary, we substitute those values into the original equations to see if it works out, right? So let's see. 2 by 3 plus 5 by 2, that's 6 plus 10. which is 16. So it works in equation 1. And then 3 by 3 plus, sorry, not plus, minus 4 by 2 is 9, take away 8, which is 1, right? So it works in equation 2 as well. Therefore, my answer is correct.